Right, Matt and
Yes.
Izar.
Okay.
All right.
Well,
Hi,
I'm pleased
everyone.
to introduce you to Izar Tarandach and Matthew Coles. Take it away.
Hopefully, everyone can see my screen share.
Yes.
Excellent. So, hi, everyone. I'm Matt, and my colleague over there in the Pirates cap is Izar. So, Zoe already did a wonderful job of introducing us, so we won't spend a lot of time here. But basically, I'm Matt. I do product security for a living. That's what I do. So I work on systems and ecosystems, and build connected products and work on connected products and make sure that they're secure from cradle to grave and from device up to cloud. Izar?
Yep. And I'm Izar, and I've been doing this security thing for apparently a long time. Done the architect bit, the engineer bit, and now I am focusing on modern SDLCs and what we can do to turn them easier to use, easier to implement, easier to get results out of. Matt and I have been collaborating since 2010 when we worked both at EMC. And we put a lot of thought in this threat modeling thing. We had a lot of ideas at the time that took us longer to implement than usually does because we spent a lot of time observing the people that we were working with and learning from the experiences that we had with a lot of product teams, both at EMC and then at other places that we worked on. We co-authored this book, the Threat Modeling Practical Guide for Development Teams. And a couple of days ago, somebody asked us, why did you write the book? And that made us think a bit more. And we wrote a book, basically, as the name says, for development teams. But we also got to the conclusion that we wrote the book for ourselves. And when I say for ourselves, for the security practitioner that has to work with product teams, with developers, with architects, with QA people, product managers, and comes to them and says, hey, we need to threat model, and meets the blank stare. And we wanted something that you could hand to them and say, come back in a weekend and you will know more than you know right now. And we will have this language, this common language to talk, and you understand what is it that we want. As Zoe said, together with her, we had the honor and pleasure to participate in the Threat Modeling Manifesto. And we are going to open up by showing up a bit of that. Matt, next one.
Standard disclaimer applies, of course. We are representing ourselves, not our employers. We have to say that.
They can't afford the opinions anyway.
All right, so today we're going to talk about some fundamentals of threat modeling. We're going to talk about some methods, and we're going to talk about, well, we're not going to talk about, we're going to show a demo. Well, we'll show a demo. We'll see how that works. And we do like interactive. So as Guy mentioned, be sure to put things into the chat if you have questions. Although if you happen to blurt it out, we'll still try to take it. But, we have about an hour here. And we'll see how things go. All right. So Izar, I will turn it over to you.
So the fundamentals. And before we go into actually that whole thing of the common language, before a couple of months, anybody talking about threat modeling would have to spend a bit of time defining things. And we would find that basically almost every practitioner had their own definition. We all struggle to explain what is this thing called threat model. And one of the, to me at least, initial good things that came out of the Threat Modeling Manifesto, for those who don't know, a manifesto is basically a public declaration of policy and aims. So you basically come forward and you say, there is this thing, and here is what we think it is, and here are the things that we think that are important for it, the things that we think that are less important for it, the things that we think need to happen for it to go forward. There have been many very famous manifestos across history. For our intents and purposes, one of the most famous is the Agile Manifesto. which we took quite a lot from in terms of structure and ideas and what they put forward and the way that they were successful. So we start the manifesto by putting forward that definition. What is threat modeling? And for these 15 experienced threat modeling practitioners, threat modeling came out as analyzing representations of a system to highlight concerns about security and privacy characteristics. So as we'll see soon, we are talking about a two-part process. We model systems, and then we analyze that model in order to highlight those concerns of security and privacy that we may have due to its own nature. Now, the structure of the manifesto is very simple. We came out with 5 basic values, 4 principles, 5 positive patterns, and 4 anti-patterns. One of the greatest things of this group was that even though we came from really, really different, distinct, and diverse backgrounds, we had people from academy, we had practitioners, we had theorists, we had people, consultants that do threat modeling. We managed to have an extremely good experience working together and plugging those differences and getting down to what you guys are going to see. If it interests you guys, the AppSec podcast of Chris Romeo and Robert Hobart, they did a behind the scenes. Actually, they did 2 episodes where you can listen to parts of our discussions and follow how we got where we got. So the point of the manifesto being to help create a culture around threat modeling with that common language, values, and principles. Let's take a look at the values themselves. The important thing to keep in mind here is that we are not saying that the things in green have to be done and the things in red are bad and you shouldn't do them and you shouldn't look at them and you should ignore them. No. What we are saying here is that we value the things in green more than we value the red things. And that's important because that value is relative. Many times we will find that because of constraints, we can't actually do anything with the things in red and we are constrained to them. But the agreement was that, for example, if we connect to a culture of finding and fixing design issues rather than just doing checkbox compliance, we would probably get a better result. If we focus on people and collaboration more than we focus on processes, methodologies, and tools, we are going to get better traction on the threat model. If we realize that threat modeling is not a snapshot of a given point in time, but it's rather a journey of understanding that system, understanding how it lives, how it gets implemented, how it gets deployed, how it gets attacked, we are going to get more of the exercise. And if we do threat model rather than just talk about doing threat model, even if it's not the best threat model, it's something that you didn't have before. So it's better to do than to talk about it. And in the same tone as the journey of understanding, if we continuously work on that threat model, because the system has a life cycle, instead of just doing it once, using it, or in many cases that we saw, put it in a drawer and forget about it, if we keep the thing continuous, if we keep it going, we are going to get better results. The principles themselves that we got to, I think that rather than read them one by one, I would just point to the keywords that we got here. We got improve, align, meaningful, and dialogue. We want the threat model to be a vehicle of dialogue between the different stakeholders, between the people doing the threat model, between the security people, the QA, the developers, the product managers. People can and should use the threat model to understand better the system that they're working on. We want threat modeling to align with the culture of the place where it's being done. We're going to see when we discuss methodologies, there are many ways of doing a threat model. There are many ways that have been found and codified, and there are many that haven't and that we haven't thought of yet. But the important thing is for the threat model exercise to be meaningful and to be fruitful, it should match the culture of the place where it's happening. We shouldn't force a methodology on a place where it's not going to work. The whole idea behind the threat modeling, the best use that we can make out of threat modeling is to improve something, to improve the security and privacy of the system. How? By threat modeling early and often. If we, as many places that we've seen, wait until the end of the life cycle, when the product is almost out of the door, to start threat modeling, we are not going to get the same advantages we would if we had addressed it at design time. Okay, so we have a question on the chat.
Yep. I'm going to go back a slide, 2 slides
Yes.
actually.
2 slides.
So Artem, so is our, I'm perhaps, I'm not
Go
sure
ahead.
when folks join. So what is threat modeling? Threat modeling, how we have here. So part of the, without going back through everything, the threat modeling manifesto attempts to define what threat modeling is, right? And so this statement here is about the most succinct way we have of describing what threat modeling is, right? Threat modeling is analyzing representations of a system to highlight concerns about security and privacy. And I'll add safety as well, but primarily for security and privacy, not to leave safety out of the stool here. Three-legged stool.
Quick question. How's it different from, say, risk assessment?
So when we're and we'll talk about that in a moment, and specifically
Okay.
the relationship of
then.
those terms. But it is different with respect to what you're looking for and how you potentially treat the results.
All right, sounds good. Thank you.
So since we are getting to brass tacks really quick, let's go back to patterns, just go pretty fast over them. Again, we have the slide at the end with the URL. So you guys can go back to the site of the threat model, the manifesto. It's very short, very to the point. There are great explanations in there. So as I said, we identified 5 patterns that promote threat modeling and 4 that hinder it. So just one example of each. An example of one that helps threat modeling would be the different viewpoints. For a long time, we thought that a security guy and a bunch of developers go into a room, talk for a long time, and out comes a threat model. And from our joint experience, it's bubbled up that no, we need more people with more different viewpoints in there. We need the QA guy, we need the product manager, we need basically everybody that has a say in how that product gets designed, built, and deployed. On the other hand, we have found that the hero threat modeler is an anti-pattern. It's something that really, really diminishes the way of doing a threat model. And by that, we mean that mythical super threat modeler, the only person in the universe that's capable to come and look at our design and immediately elicit all the threats, figure out all the mitigations, give us a list of everything that we have to do, and then leave through the door towards the sunset. No, we believe that everybody should threat model, that everybody can threat model. And there are different methodologies out there that at different levels enable people that have more or less experience with security to do something around threat model. Okay, so with that, Matt, now it's you, I believe. Yep.
Yep. And there's a few questions coming in. We will try to address them. SS, you were asking about difference between security architecture review and threat modeling. And Tyrone, I think, was reiterating the question regarding threat modeling and risk assessment. So we'll try touch upon those things. I'm not sure we'll be able to answer them directly, but we'll try to do our best. All right, so given the understanding of what threat modeling in this now new common lexicon of what threat modeling is and what it represents, and keep in mind, of course, that this is really a collection of people got together and put a stake in the ground and said, this is what we think threat modeling should be. right? And it is not necessarily that there's nothing outside that bucket or outside of that scope, but so that we get consistency, what is this thing when we call threat modeling? In order to do threat modeling, there's some basic things that we need to understand as practitioners, right? And so that's what we'll talk briefly about here, and then and maybe that will either generate more questions or maybe answer some of the others. So whenever you have a system, you're going to have data and you're going to have functionality, right? Really core basic thing. You have a system, something that does something. It has functionality, it has things that it does, it operates, and it has data that it may be storing or that it's operating on, or that it's just passing back and forth, right? And we want to be able to protect that data and that functionality. We want to protect it against some core things, right? We want to protect its confidentiality, right? We want to protect its integrity, and we want to protect its availability. Now, for most of you, based on the introductions, these are probably terms you've heard before and things you're very familiar with. For some of the other folks on the call today who are students of cybersecurity or are in other fields, these may not be readily apparent to you. So feel free to ask questions throughout all of this. But basically, we want to make sure that we are protecting data from prying eyes, that you can't see data that you shouldn't have access to, and that things don't get tampered with, or they're available to people, or available to a user or a process of the system when they want it to be available. So these are some of the core things that we want to protect in a system, of course. And how we do that is we're going to apply a few things, right? So we're going to apply a set of controls, right? We want to make sure that we have certain controls in place that allow us to maintain this confidentiality, this integrity, and the availability. Some of the core controls we're going to apply is in the area around primarily access control as a core fundamental part of how do we protect these security properties, right? So we have to have the means of identifying who wants, someone who wants to do something, that they can prove who they are through authentication, that we can make an authorization decision, right, on what they want to do, and that we keep track of what they do, right? So these are some of the basic controls that we're going to want to make sure that exist in a system in order to preserve the properties of the system. We're also going to want to look at certain patterns, right? We're going to want to look at whether or not the application or system is built with defense in depth in mind, right? A castle, if anyone knows, has seen a castle or a house for that matter, you don't have just a door, right? You have a door and a lock, or you have a moat, and so there's lots of ways this can happen, but it's all critically important to have defense in depth for a number of reasons. We also want to make sure that a system runs with least privilege. This is a critical way for ensuring these security properties, and these are patterns that we're going to look for, especially during, say, a threat modeling activity. Guy, I will get to your question, I think, in the demo. Fail secure is a critical aspect of threat modeling or of system design in general, and something that we look for during threat modeling. And complete mediation. Do we perform the security checks in the right time and consistently throughout the system? And then lastly, and this is not a complete list, but these are examples of things that a system needs to have in order to ensure security. There's a set of capabilities that application or that system is going to have, right? Is data going to be can data be protected again from prying eyes, from a lack of confidentiality? Do we have strong credentials when we perform authentication? And as an example here, do we prevent malicious code from executing? So these are some of the things that are critically important for secure systems, and these are things that we want to look for when it comes to threat analysis, to ensure that we don't have any major concerns. So given this, Now let's talk a little bit about terminology within the scope of threat modeling, not just threat modeling, but it appears in other places. So again, we have a system, and that system has data and has functionality. And that's all wonderful and that's great. And that gives us value, right? So now somebody asked earlier about risk, a risk discussion. Here we're going to introduce some terms just as a basic introduction, which dovetails with risk. So we have a system, has data, has functionality, that gives us value of some sort, right? The problem is, as developers, we sometimes introduce bugs, right? Never happens. Nobody ever codes bad code, right? Well, in a security sense, or in the security space, these bugs, we call them weaknesses, right? So if you have a buffer overflow, you have a weakness in code. And this weakness can cause some negative impact, right? This will influence our value, right, of a system. And that can exist in the system as a whole, or it can exist in a particular piece of functionality. And these weaknesses accumulate over time, right? And some of these are going to be exploitable, right? And when they're exploitable, we now take that weakness and we call it a vulnerability, right? And so these vulnerabilities are things that are going to help somebody execute a threat. So a threat is something that is used by a threat actor to exploit a vulnerability to impact the system, thereby impacting its value. And it's that combination of things that generate risk. So threat modeling itself, as the name implies, is to help us understand what threats and potentially then what vulnerabilities we have that can be impacted and be exploited by an individual, and that has a negative consequence, right? And so we want to understand that part of things. I'll say that the risk side of things is a little bit beyond the core or traditional threat modeling boundary, in that threat analysis is really trying to figure out what can fail, what can go wrong, and what are the paths to have that happen, and providing information into a risk management process to understand how bad that's going to be especially from a financial impact. But now, just because we have a vulnerability and because we have a threat and somebody who may be able to take advantage of that threat, that doesn't necessarily mean that automatically means we're going to be exploited. Often, and this is a common theme these days, just simply having a highly severe vulnerability does not mean that you're at imminent threat of being exploited and attacked. And so fundamentally, what does a threat actor need to have also in order to actually have this be a problem? And it's something that threat modeling can only do so much for, and it's important for the risk discussion, which is why we're bringing it up here. So a threat actor needs to have a means, right? They have to know how to exploit one of these vulnerabilities that cause this threat to occur. They also have to have a motive, right? They have to have a reason to come after a system that has a vulnerability, and they have to have an opportunity, of course. So you have to have means, motive, and opportunity, right? Basic requirements for a crime to exist. But then more importantly, and this is what separates security researchers, as an example, from, I will avoid the word hacker because of the connotation here. It's not meant to be negative for a hacker security researcher, but to be a criminal is they have to have the will, right? So you have to have the means, you have to have the motive, you have to have the opportunity, and then you have to have the will to go ahead and exploit a vulnerability. And all of this influences risk. And this is where the risk discussion comes in. So threat modeling proper tries to figure out who's going to do what against the system and how they might influence the system to cause some impact. Sorry, if anyone can hear through my microphone, my cat is going nuts at my door trying to get in. All right. So Adam. Hi, Adam. How you doing? Wonderful question. So Adam was asking, and I'll go back to the slide. So will versus motive. Just because I feel I need to do something doesn't necessarily mean that I will take action on that. So having a motive versus having morals that prevent me from taking that action is that differentiation. All right, great question though. All right, so now the pressure is up, and Adam missed the beginning of the presentation. So as long as it is somebody who's not spoofing Adam, that's okay.
Wait. I think that it's worth a parenthesis here. For those who don't know, Adam Shostak wrote the first big book on threat modeling, and he has pioneered a lot of the techniques that we use today, some of the most well-known. And he is well regarded as the guru of threat modeling, and we are very happy to have him here.
He's also one of the 15 individuals that we were talking about previously
Exactly.
for the Threat Modeling Manifesto. And you'll hear him speak on some of the security journey behind the scenes recordings, if anyone gets a chance to take a look at that. Okay, so now we're going to talk a little bit about modeling. So there's two parts to threat modeling. Well, there's two fundamental parts of threat modeling in terms of building a model and then analyzing that model for threat modeling. So we'll talk first a bit about the modeling part. So there's some basic shapes, and I'll let me just preface this actually now that Adam's here, his presence reminds me that there are a lot of different ways to do threat modeling. So what we're going to present here is really sort of a traditional way of generating information for a model that can be used in the threat modeling activity. There are other ways of doing this that don't require graphical graphics to do it, but this is the most common way of doing it. And these are the most common shapes, which we'll be talking about. So this is by no means complete. This is just an option. So there are a number of different shapes. These are the DFD or data flow diagram shapes that we'll be talking about. And there's a plethora of tools out there that have stencils that have these shapes built in. So the first one is a circle. Pretty basic. This represents a process. This is a thing that takes data or passes data or has interactions within the system and does some task, has some functionality. And this representing as a single circle is a process which is sort of a self-contained functional unit. So this may be an executable, or it may be a process, a thread or some thread of execution or something like that, that you want to represent in the system. A double circle represents something that is complex, something that you're going to take to a next level. You're going to say, we're at a certain level of granularity or specificity, and then we're going to subdivide this and figure out the subsystems and subcomponents within to understand how things interact. The parallel lines represent a data store, how data is stored, where it's stored, and basically it's a place where data goes in the system. And then, of course, because this is a data flow diagram, you have to have data flows, right? So we have ways of describing how data passes between objects in the system and understanding that data can be unidirectional or bidirectional, right? I will add, I'll make a note here that the little tick marks that are added here, these are something that Izar and I actually introduced in the threat modeling book as sort of a helper that we've found over the years to indicate who initiates the communication. So while a traditional data flow diagram doesn't use these, we find it adds value in terms of indicating which endpoint is initiating communication. In many cases, especially if you're doing, say, TCP communication, there will be obviously bidirectional communication that occurs, but for the purposes of the modeling exercise, we really care about who's sending data where, and not necessarily the protocol information that's continually passing back and forth. And so this little tick mark just adds a little bit more context that allows us to make additional decisions when it comes to the analysis side. Totally optional. We recommend it, but it's not in the standard stencil. And then the other big item here is trust boundary. So each of these processes and other elements in the system may be operating at certain privilege levels or at certain trust levels between them. And so a trust boundary is really exactly what it says. Where does the level of trust change in interactions between components? And that's what this dotted line curve thing is meant to represent. And Adam, Izar, since you have the mic, if you have anything you want to add there, please let me know. Otherwise, I'll continue.
Go for it.
All right. So then, as part of building a data flow diagram and ultimately in order to get to the stage of doing analysis, we also have to then describe these things, right? So it isn't just so much that we, actually, let me go back. Right as it is, this diagram is telling us something, right? This is telling us that we have two components that talk to each other, they exchange data. I don't know what's going on screen here. Sorry. Artifacts of Zoom, perhaps. So we have two things that are talking to each other, and that one of them stores data, right? That much we know, but we don't know any of the other details about it, right? So that's where we need to provide information, right? So you can do annotations here. These are just bubbles. You can create notes, text, whatever you want to do. In this case, process A is a web server. In this example, right? It authenticates users. It runs over HTTPS, and it runs on a front-end server. We have process B that is our database. It runs over a particular port. It's written in Java, yay. And it runs privileged for some reason, right? Of course it does. And then we have a data store, right? Our data store has certain properties as well. And then we're going to want to annotate our data flows as well. And it's with this information that we will start to look at this for weaknesses and vulnerabilities, as well as if there are any potential threats that result from that. I know we probably can't do this live, but if anyone wants to put into chat, if they want to just call out, is there any security concerns that they might have? Quick poll for folks. Are there any security concerns that people might see in this model? Dan, you called out injection. If you can clarify that. What kind of injection? Okay, possibly. Now, we technically don't have enough information here to make that call, but it's a good call out in that we are doing SQL queries, so it is absolutely a potential. We can't necessarily make a determination from this information directly that it has SQL injection, but it certainly does warrant investigation. Are there other areas of concern? Waj, yes. Passwords storage could be a problem. Sam, good call out. Yeah. Yeah, so there's quite a few areas of concern here, right? And so with just a little bit of information, you can start to make some judgment calls to understand where where there could be problems. Well, Artem, HTTPS authentication is not necessarily a problem. Actually, that's usually a good thing. But there may be other problems here, right, with respect to how those authentication credentials are passed throughout the system. Nobody's picked up on the data store's permission level over here yet, but that always gets fun and exciting. Yep, good call out, David. Yeah, Sam, in this case also, this database server is not running by default secure. So good call out. Yeah, so as you can see, a good amount of information can be gathered and quickly from this conversation, quickly identify areas of concern. So we just did a basic threat model. Pretty straightforward, huh? Yeah. There are probably so many vulnerabilities in here that we could go on for hours. All right, I'm going to move forward. Thank you. That was great. But hopefully this was really obviously a quick introduction, but this is a basic threat model. I mean, this is basically what you do, right? You model a system and then you analyze it. And so speaking of analysis, part of the analysis part is there's lots of ways to do analysis. So there are a few ways to do modeling, right? Primarily through data flow diagrams, but there are other means. And then there's lots of ways that are well accepted means of doing analysis. And so we're going to touch upon a couple of those today, and there's a list of probably 30 or so, but we're only going to talk about 4 of them just for real estate on slides here. So we're going to start with the basic one, Stride. Thank you, Adam, for Stride. And so Stride is pretty straightforward, right? Stride is security focused, and it does what it does, right? It does what it says it does. You're looking for instances for threats of where spoofing and tampering, repudiation, information disclosure, denial of service, and escalation of privilege occurs. Thank you, Adam, for the correction. Most people think it comes from you, but we'll make that note that it comes from, from other folks. You did a lot to evangelize it. And it's very common, right? A lot of people do Stride. And there are a lot of variants on Stride, right? And in fact, one of the variants on Stride we want to call out is actually privacy focused. So taking the structure of how Stride was built, which is basically take a model and take a model, whether you're using a DFD or using something else, to look for a certain set of threats in the security space. Linden, as a privacy-centric modeling approach, is looking for a different set of threats in a very structured way. So here we take a model and we're looking for certain properties that would suggest that we have privacy threats to be worried about. And then lastly, we have in this sampling, in this set, we have CTM, or continuous threat modeling. So continuous threat modeling is something actually that Izar pioneered with a few folks, and there are various forms of this running around now, around how do you get threat modeling into an agile process in a more structured way. Traditional threat modeling has been seen as very onerous from a DevOps or agile standpoint, and CTM tries to help with that. I'm not gonna make any judgment call about whether Stride or Linden are in fact heavyweight for agile processes, but CTM is geared specifically for that purpose, and it basically again starts with the model and then using this approach of if this then that to understand, if you have this construct or this property exists or this feature or capability exists, these are the threats that you may have, and here's how you might approach resolving those. And so it allows, in a very agile way, it also starts from a core, the core position of this is based, and Izar loves to talk about, loves to make this statement, I think, is, threat model every story. And so as you're building out a system in an agile fashion, keep in mind that every time you have a story, every time you're writing code or you're adding a feature or implementing something new, you have the potential of introducing new threats. And so that's where CTM really tries to inject threat modeling into the right process. Izar, do you have anything you want to add on that?
That was perfect. Thank you.
Excellent. So as I mentioned, these all start with a model, right? So these are primarily graphical based or model based, and then they lead into analysis. By comparison, we have something like Tara. Tara gives you heartburn sometimes. So Tara is a very structured approach for doing threat analysis, and as the name implies, threat assessment and remediation analysis. It is used heavily in places where functional safety, especially, or mission critical systems are involved. Primarily in defense applications, but also in automotive and those other safety critical environments. But rather than starting with a model, it's really looking at a set of assets and then diving deep into how adversaries will attack those assets and what the impacts will be. And it's very spreadsheety and catalog based and very structured. It's very heavyweight compared to especially something like CTM, but for what it does it really well, right? It is designed for being very complete in its analysis, and it has to be for the types of environments that it's targeted for. And so really what we wanted to I guess to express here, without going into a lot of detail about each of the individual tech approaches, is that given that definition of what threat modeling is and all those principles and values and patterns and anti-patterns, that all of this fits within the threat modeling umbrella, right? And so whether you're doing Stride or CTM or Tara, it's still threat modeling. It's just different ways of doing it. And you're not, one of the things we didn't really talk about is, the threat modeling manifesto is to use tools when you can to facilitate the effort, but not let those tools run your life. Right, the tools are not there for you to run you. You're there to run the tool. And I probably didn't say that right, but anyway, all of this fits within the umbrella of threat modeling. You can't really go wrong, maybe, as long as it works for you, right? I think we're going to jump into the next section. Actually, yeah, we're going to go into about pytm. Before I go, does anyone have any questions that they want to ask at this point? Or Izar, do you have anything else you want to add on any of this?
Not. I guess that the only thing that I can add here is that CTM is really geared not only for the agile environment, but also for developers. So it's trying to bring threat modeling down to the ground floor with that threat model every story thing. And just one clarification there, it doesn't mean threat model every story. It means examine every story, figure out if it has a security value or a security component, or if you're doing something that warrants security. That one, go on a threat model, but if it doesn't, if it's a simple story, then just move on. That's usually something that for some reason people get a bit hung up on. It's not every single story has to go through the whole process, but it's really geared towards something that developers can do.
So Artem, this is a great question that you asked. So how do you know, so Artem asked, in case folks can't see it, how do you evaluate if a modeling approach, an analysis approach, is a good fit, or if it's working right? So keep in mind that one of the foundational parts, one of the foundational principles of the Threat Modeling Manifesto is that threat modeling has value if it's meaningful for you. And so you you figure out if a modeling approach is the right fit for you, if you're getting value out of the output, right? So is it something that you can get people to adopt, to do, right, to execute on, and in the execution, do they get value out of it, right? If you're just drawing pictures on a whiteboard and putting notes together and nothing comes out of it, that's probably not very valuable. If you're doing all of this work and you're not making any good risk decisions from it, or you're not able to defend the system as a result from it, then it's probably not a right fit either. And so it really is, unfortunately, there's no way to say, well, this is going to be your, Linden is going to be the thing for you, right? It depends on what your goals are. It depends on what the systems are that you're looking at. And it depends, I think, on what your organization looks like. And so it is a trial and error approach, I would suggest. Izar, your thoughts?
Nope, I'm good. And actually, those that don't see it, Zoe put on the part of the threat modeling manifesto that addresses that, and it is the outcomes of threat modeling are meaningful when they are of value to stakeholders.
So unfortunately, there's no good answer. There's no quick answer, I should say, Artem, for your question. Simply whatever gives you value and that you can get value from. Okay.
There's a value, yeah.
All right, so moving on. So we're going to get to the demo in just a moment. But before we get there, so somebody had asked earlier about how do you, somebody asked earlier about, or mentioned earlier that they were interested in automation. So pytm is a Python-based threat modeler. I don't know how we came up with this name, pytm, for such a thing. And so this is an open source project. It is it's on GitHub, and it's an OWASP project at this point. It is a system that allows you to define something that you are wishing to model, and then it performs analysis for you, looking for threats and other areas of concern. And so how does it do that? Well, in order to build any such system, there's some basic things, right? So pytm has some of these things, and any system that's going to be able to do automation of a threat model has to have some core pieces, right? So the first thing, you have to have some sort of information model, right? You have to have the ability to describe a system and provide its properties, similar to what we did on the previous slide there, where we had, those circles and they had the data flows and we had annotations. We have to be able to provide that information to a computer to a computer program, right, that can do the interpretation. So here, as an example, we have a schema for an element, right? Something that sits in the system, one of those circles, a single circle, double circle, whatever, however it gets visualized. But ultimately, those things represent parts of your system, right? So you may have a web server. That web server, so you have a type of system. You have a role in the overall architecture. It's going to expose certain services, or it's going to listen on certain services, or it's going to be connecting to certain ports, or make connections to other things in the system. Or you're going to run with a certain privilege level, or contain other components, right? There'll be subcomponents and subsystems. So all of this stuff has to be able to be described in a way that a computer, rather than a human, can interpret. The computer is going to do that through a set of rules, right? And at the core part here is we can look for, say, a weakness, right? Do we have a weakness in the system? One of those defects that could potentially be exploitable, versus do we have a potential threat in the system, where, do we have, and this is just completely made up, the pseudocode here. This is not from pytm specifically, but these are examples of you'll have some sort of rules that take that element, that schema information, and make the determination of whether you have an area of concern. And then lastly, you're going to have some sort of engine, some sort of functionality that allows you to load in this model information, parse it correctly, put it in some sequence that makes sense, do analysis over that sequence, and then render output. And in particular, you may render graphical information as well as threat information. And you may also want to have a calculator to be able to do, say, severity scoring or risk scoring. And so these are some features that the tools like pytm, there are other tools out there, but these tools have these things. And so if you're going to build a system, these are what you need. pytm doesn't have all of these, but it is evolving. All right, Izar, I'm going to pass it to you. I will drive. Let me know.
Okay, so confession, I'm going to cheat a bit. Why? First of all, because Mr. Murphy is one of my best friends. Second, it's 8 in the evening, and when I get tired, my fingers get strange. And third, because I just learned how to do slides with code, and I'm really enjoying it. So what I'm going to do is show how we define the components of the model and the relationships, the data flows. Then show how we generate the data flow diagram or the sequence diagram with pytm, and then how we can annotate those elements with attributes, and in the end, the final report that pytm produces. Now, what I want you guys to have in mind is that pytm is, rather than a system, it's a library. So you import pytm, and it becomes part of your script, and that script itself is going to describe the system that's going to be analyzed later on. So what does that look like? This is the skeleton of a pytm model. The first part, I think, click on something. Yeah, the first part is familiar to anybody who ever wrote Python code. It's just importing from the library those elements that we are going to use. So you always have to have the TM, and you can pick and choose what you're going to use. So actor, boundary, classification, data, so on and so forth. They are objects that we define as part of the library that we're going to see the use soon. Next one, Matt. Yep. So that one is the real one that absolutely needs to be there. Without that, pytm doesn't know what to do. So we define a threat model object, and that's going to hold all the information. We give it a name that it's basically user's choice. It's not going to appear anywhere. It's not going to influence the analysis in any way. And then where we see the ellipses is where we're going to put our system, our elements. And at the end of the definition, we're going to call tm.process. What that does is it picks the command line arguments and does what we asking there using the model that we just defined. Next one, Matt. So this piece of code goes instead in place of that ellipsis. You can see that the blurred lines are the definition of the TM and the call to TM process. What we're doing here is we are defining 4 elements for our model: the user, the client, the server, and a database. Again, we give them names. These are going to appear in the diagrams, but the calls are pretty simple as they are. The importance of the thing here is that you don't have to be a Python developer to use pytm. You have to be able to run a Python script. The whole thing, apart from the skeleton, is basically creating an object and using the object.attribute equals value notation to, again, annotate that element. So if we move to the next one, we see that here we are starting to create the data flows. We are starting to say how one thing talks to another. So just to pick one randomly, Matt, I think that, no, go back. Yeah. So let's look at the first one, the interact. That's a data flow that connects the user object to the client object. And what goes over that data flow, the customer accesses the system. Something basic, something clean, not a lot of detail at this point. Now, if we just have this on the script and we run the script with --dfd or --seq sequence, what we get is this. The system is able to generate a basic data flow diagram or a sequence diagram from exactly the same script, exactly the same input. The only difference here is the command line argument that we apply when we call the script. Now, if you look at the data flow diagram, it looks pretty similar to what Matt opened up with. We have somebody talking to a client who talks to a server, who talks to a database, data goes back and forth. Now, the first thing that we could do that would enrich this and start giving us more ideas of what's happening here would be to add trust boundaries. Trust boundaries are limits that show that values of trust are changing from one side to another. So in this case here, we define two. We define the public boundary and the protected boundary. Yeah. So we just basically create one more object called a boundary. But now, Matt, we start adding to our elements using, again, the object.attribute equals value. And in this case, we are saying the user element lives inside of the public boundary. Then we do the same thing for the client, and the server and the database live in a different one. Now, when we generate the data flow diagram, what we get is that. So just by adding a bit of attributes, we start getting something that's graphically a bit more not only pleasing, but also has a bit more of semantic value from what we are seeing. Next one, Matt. Now here, what we see are examples of attributes that pytm supports right now. So you could say that the server is running a specific OS, that it's been hardened or not, that it knows how to sanitize its input or how to encode its output, and that it authorizes the source of its data flows, and so on and so forth, up to, for example, the enter data. The enter data is a data flow, and we are saying the protocol that goes over it, it's HTTP, the destination port, what kind of data goes over it. The call out in there, the max classification, is something that we are introducing in, well, we already introduced in the version that's on GitHub, but that we are refining. And it's an attempt to visit both confidentiality and privacy a bit better. We want to be able to, given a set of objects, of data objects, we define a data type called data, that among other things says what is its own classification. So by annotating that together with annotating both data flows and elements, saying, hey, what's the max classification of data that you are supposed to have, we can start detecting data leaks by saying we have data of a higher classification present in an element or data flow of a lower classification. So this is one of the latest things that we have. Another thing that we introduced in the last release, I think, but that we are still working on, is the concept of levels. When you do a data flow diagram, you usually have the choice of zooming into the picture by doing a level 0, level 1, level 2. On each one of the higher levels, you have a higher level of zoom of the system that you are modeling. So we recently added that to pytm as well. You can say that one element is present in a given level. And then when you ask for the diagram to be generated, you can say, I want these levels to be taken into consideration. And that happens both at the diagram creation and at the threat elicitation, when we try to figure out what's the list of threats that this system is subject to. We take the levels into consideration so that things can be a bit more granular. Next one, Matt. We also have this nice template language. You can use any kind of text-based format. We are very agnostic. Actually, pytm tries to follow the Unix tool philosophy of having small tools that know how to do one thing well and don't try to do the whole thing by itself. So for example, to generate the data flow diagrams and the sequence diagrams, we use GraphViz dot and PlantUML. So we output text that those tools know how to interpret and generate the diagrams. And in here we see the translation of the template in a markdown format, how it appears in the final report. Matt? Now this is a sample of the final report as it comes from the default template that we supply together with the library from straight from GitHub. We see up there it's a level 0 DFD. It has the data flow diagram that we generated, a list of the data flows with its details. We didn't actually define any data object, but because I had that classification in there, we get that data dictionary in there. And then we start with the list of potential threats. Now you see that there's an arrow by the side of each one of the threats, and you can click on it, and what you get is this. Matt? I think there's an animation here. Matt, click. Yeah. So we get the targeted element with the name as it appears on the data flow diagram so that you can relate back to the diagram to position yourself. We give it a severity, but it has to be said, we are not calculating the severity. It comes basically from the average instance of a vulnerability that actually realizes that threat. So there's no calculation in here. There is no, we are not divining where that severity comes from. Then we offer some example instances and some mitigations, and most important, the references. We refer back to known good sources of information like CWE, like KPAC. In fact, we are listed in the KPAC page as one of the projects that consumes it constantly, and it's great to be there. And that's basically pytm. You write a script, you get your diagrams, you get a list of possible threats, and two things to keep in mind. It follows a garbage in, garbage out, meaning what you get from it is going to be only as good as the amount of detail that you put in it. And something relevant to these times, what we had in terms of good experience is people working remotely, using pytm as a way to generate the first diagrams in their threat model. So in this way, they're not as interested in the threats at the end, but mostly as because it's source-based, you can just make changes, send it back to the repository, in that case was Git, and the person presenting would pull the latest changes, run the script, get the new diagram as people were actually discussing the design, the nascent design of the system. So it turned out to be a very good tool for a remote meeting. Another thing is it's by developers, from developers to developers. So there is a link between pytm and CTM. It's again that intent to make the thing accessible to developers. The good thing about pytm is that you can maintain the code that describes the system together with the code of the system itself. So even though they are not supposed to touch each other, it's very convenient to have both stored in the same place and basically evolve at the same pace. You can even check if a lot of time has passed between the time that the source changed and the time that the pytm model changed, and flag that as, hey, perhaps it's time for somebody to pay attention. Is the threat model evolving together with the system or not? Anecdotal, that there is some very good feedback that we have got over the past 2 years on pytm, and I hope it's useful to you guys too. So without further ado, questions? Not only pytm, but anything. Well, not anything, but you get my gist. Nope.
And then lastly, we have a set of resources. So thank you, Zoe, for posting links into the chat. And just, some of the things that we call out here. Obviously, the book, the manifesto, pytm, continuous threat modeling as a methodology. I want to also call out, Adam Shostak and his threat modeling book, Brooks Schoenfield's book around securing systems. For the user who was interested in architecture reviews versus threat modeling, Brooks' book is more along that lines of secure system design and less around strictly threat modeling. And then lastly, SafeCode, the Software Assurance Forum for Excellence in Code, has produced a paper around tactical threat modeling, which I think Izar contributed to as well, which is a good, easy read and resource for folks who might be interested in that. All right, I guess we'll turn it back